Okay, welcome everybody. So today we're going to talk to you a little bit about the Python raster function and processing imagery using Python raster function. How many of you are familiar with the Python raster function or have played with it at all? One. Wow. How many of you are familiar with functions, raster functions? Okay, so you are familiar with the raster function framework and how we're using that. So I'm going to go over function basics for those of you who don't know. I'm not going to spend too much time on it. And then we're going to dive into the Python raster function API. And then I'm going to show you a little bit about how they interact with Mosaic data sets and items in a Mosaic data set. So, raster function. What is a raster function? A raster function is a mapping of one raster to another. So what that means is we're not actually generating an output like you typically would see with a geoprocessing tool. We're not taking an input, processing, and outputting a TIFF. We're actually doing this on the fly or in memory. So because of that, it can be really fast. We're only really processing the pixels that people are looking at in their area of interest. So so it's on demand, it's very transient, and very fast. So like GP tools and GP models, you can chain raster functions together. The experience in 10 is a little different from Model Builder, but in Pro we actually changed the function chain editing experience to be very similar to Model Builder, which most people are very familiar with. The only strange thing about it is it looks so close to Model Builder that people are thinking they can drag GP tools in there, but you can't. So just be aware that GP and raster functions can't live together currently. So you can apply these functions to a data set. So you can take a single raster data set, apply it. You can apply it to an item in a Mosaic data set. You can apply it on top of a Mosaic data set. And you can actually create these templates and store them with Mosaic data sets. So I can have a series of templates that process a single Mosaic data set. And I can store it with the Mosaic data set and publish it as an image server. And end users can actually flip through these templates and apply them. So they're fairly versatile. They're very lightweight. They're stored in an XML file. So they're very lightweight. So yeah, that's what a basic function chain. This is a Landsat 8 pan sharpen function chain. So we have all the bands here on the side as individual rasters, and then in here we're actually getting raster info, and then we're doing a composite bands as a function. So this isn't a GP tool. We're doing this as a function, extracting bands, pan sharpening, and applying a stretch function. So that's what a basic function chain looks like, and I'll show you one in a second. So I'm going to quickly demo a basic function chain. So here's a function chain I built in Pro. You can open it and edit it. Oh, you can't see it. Sorry. Let me start that over. So yeah, so here's a function chain that I built in Pro. You can edit it. Kind of looks like a model, right? You can drag functions in it. Here's a bunch of our out-of-the-box functions. There's a fairly large, extensive list of them. You can drag them in here, just like anything else. So it's very much like the Model Builder experience. Here I have a basic one that does vegetation disturbance, so it detects vegetation disturbance in Landsat using tassel cap. So I'm doing a tassel cap here. I'm extracting bands in here, so I'm extracting all the bands. I'm doing some math on it in a calculator. So this is like the raster calculator, but as a function, same idea. Then I'm clipping and remapping the pixels so they have meaningful colors. So that's a basic function chain. What's great about these things is, you can actually, not only are they good on desktop, but you can actually publish them, share them to portals. So they're portal items now. So you can make a bunch of these cool function templates and you can send them to portal. You need to give it a summary and a tag, and then you can publish it. And then as an end user, you can go to portal And you can search for RFTs now. So RFTs are now portal items. And so you can apply them directly from portal to your raster, or you can even, if you open a new function editor, you can actually drag these things directly in, and you can use them yourself. So that's a basic function chain. You can apply them fairly easily, so I can apply it to a raster data set. So the only thing I really exposed out of this function chain was the input raster. You can expose different parameters like you do in GP, but right now I just have the raster parameter exposed. So you can create a new layer for it. So this is creating a function raster layer. It's a temporary raster layer on disk, and it's actually detecting vegetation disturbance in this Landsat scene. It's pretty fast, pretty performant. It doesn't take much time to apply, and it's really only applying in the area of interest that I'm looking at. So it's a dynamic function. So I'm going to hand it over to Zoey. So you can do this. I'm showing all this in Pro because it's a little easier and it's a little more user-friendly, but you can do this all in 10x too. So I'm going to hand it over to Zoey, and she's going to show you how to apply the same template in 10.
So in 10, you have your image open in the image analysis window. You can open your image analysis window by going through here. And when you highlight that, you click this apply function template, and then you select your function. Click apply, it's applied. So that's how you do it in 10.5. Back to Jamie.
Okay, thanks. Okay, so as we started building out this function framework, we decided that there should be a better way for people to build their own custom functions. So we decided to build this SDK. We had an SDK for function development prior to this. It was all done in .NET, which was great, but a lot of the scientific community was like, man, why don't you do this in Python? There's so many cool array processing libraries in Python, like scikit-image, NumPy, SciPy, scikit-learn. So we decided to overhaul it and move it all into Python. So this is the same idea. So we're transforming one raster to another, but we're pipelining it through Python. You can do it all in the comfort of your own Python module. Again, you have access to all the cool free Python libraries that are out there. So these Python raster functions are first-class participants in the function chain. So it looks like a node in your function chain. So to the end user, you can as a developer, you can write these Python raster functions, and then you can build an RFT out of them, which I showed you. And then you can send these RFTs to your end users, and they can use them just like any other function. They don't need to know Python. They don't need to know anything about it. They can put them in their models just like any other function. So same idea. So here's a quick SketchUp of what a Python raster function looks like. So this is a node in my, if you look at this node here, this is a Python raster function. It's powered by the Python raster function, and it's backed by a Python script. So it's just the same idea, just backed by Python code. And again, you can put it in all the same places you can with a regular function. So why Python? Again, we really wanted people to start doing this in Python because there's a lot of demand from it from the scientific community. We're trying to push people into the function framework because it's a lot faster, a lot more portable than GP. People were waiting days to process large amounts of imagery. Now we're doing it on the fly. We're doing it instantly. It's very portable, it's very reusable, it's very dynamic, and it's scalable. And again, why Python? I already explained it. Okay. Oh, sorry, do you want to get a picture of that? Okay, so the API. So how do I start? Where do I go? So we have a GitHub repo that I'll show you guys at the end of this. We do have a wiki doc in there, so you can go through it and go step by step. But we do have a lot of samples in there. Bless you. So what other libraries are needed? To begin with, just NumPy, which gets installed with Pro and 10 at this point. But again, you can extend it to whatever you want to use. But just for basic use, you can just have NumPy. So here is a snapshot of a very basic Python raster function. At a minimum, it needs the init class, which stores its name and its description. Parameter method. So this is where you define all the parameters that you're going to pass in or have the users pass in. And then update pixels. Update pixels is not necessary, but if you're doing image processing or if you're going to apply some algorithm, this is where all the work happens. You're passing in the pixel block, doing something with the pixel block through NumPy, SciPy, and then outputting a new pixel block. So this is a basic look at a very basic raster function. And I'm going to step through all the other methods as well. So here's the init. The init method, again, stores the name and the description of the function. So when you put it in that method, the end user sees this when they open the raster function in the general tab, the name and the description. This gets initialized every time you apply the function. The next part is the GetParameterInfo method, and I'll show you a working example of this. So the GetParameterInfo method actually is where you define the parameters that are going to be passed into the function. Currently, the parameter types that we have available are rasters, table, raster, single raster, numeric, and I think that's it as far as input types at this point. But I think we're going to extend that over the next couple of years. So for each parameter, you need to define a name. So that's the name you're going to pass into the code later on. The display name, that's what the user sees. So you can have a different display name from the actual parameter name. A description, so when you hover over this, we'll have a description of what the parameter is. And in Pro, you can just hover and it'll have like a tooltip pop up. The data type we already talked about, a default value if necessary, and required versus optional. So you can make parameters required or optional. So the get configuration method. This is how input rasters are read. So you can add padding to it. So if you want padding to the pixel block if you're crawling through a pixel block, you can add padding to it. You can apply masks. You can inherit properties from the input rasters. So if I have an input raster with a certain bit depth, you can inherit that to the output. You can also set it manually, but you can inherit properties from the parent image. So this is the get configuration method. You can also disable properties from the input raster as well in here. And I'll show you a working example of this as well. Select rasters method. So the select rasters method, so given a stack of rasters, you may not want to pass all these into your update pixels method, and you might not want to sort through them in the update pixels method. So you can actually choose rasters from a stack. So if you're given n rasters, then you can actually identify which rasters from that stack you want to use in the select rasters method. And that's done for performance reasons. If you have a giant stack, you don't necessarily want to pass that all into the update pixels method. The update raster info. So this is what stores all the output info. So you're constructing an empty container at this point. You want to define what the container looks like, what the output raster looks like. So that's all done in the update raster info method. And then the update pixels. Again, this is the workhorse of the Python raster function. This is where you're putting all your image processing algorithms. You're passing in an input pixel block, you're doing something, and then you're outputting a pixel block. So this is where most of your code is going to go. This is where you're really going to do most of your coding. Update key metadata. So with rasters and sensor types come key metadata. So sun azimuth, acquisition date. You can actually update this in this method. You can actually change the key metadata of a raster on the fly with these functions as well. So if you want to change dates or change sun azimuth, you can do that. And isLicense, the isLicense method, you can license these things too. So you can build in licensing. So if you don't want certain people to use these, you can do that as well. So that's that. So let me show you a basic Python raster function here. So here I have a Python raster function that calculates compound topographic wetness index. It's fairly basic. It takes slope and it takes flow accumulation, 2 rasters, and does some math on it, and it calculates a steady state wetness index. It's a fairly basic Python raster function. But I'm going to show it to you in code. It was something that someone that worked here developed, and they're actually using it currently in real use scenarios. So I'm gonna bring it up here. Can you guys see that? Oops. No, you can't.
View presentation mode. Enter presentation mode.
How about that?
Better?
Can you guys see that? Is it bright enough? Too dark. Dang.
Maybe open a notepad.
Let me just open it in Notepad.
Close it.
Better? Okay. So here, you can see it. Okay. So here's a basic Python raster function. This is our CTI Python raster function. So here's our init method. It's just the name and description. It's most basic. I'm importing all the libraries I'm using up here. So I'm importing stuff from NumPy and from math. The next method is the getParameter method, ParameterInfo method. So here's where I'm defining the parameters. So here's the name of the parameter. The data type is raster. The default value is none. It is required. The display name will look like this, and the description is here. The next one is the same thing. It's a raster. The name is flow. It's a flow accumulation raster. So that's how you define your parameters. Here I'm setting some properties. I'm inheriting properties from the input raster. So the input raster is going to be the first raster in the list, if not defined. And I'm invalidating properties. I'm resetting stats. I'm getting rid of the histogram. I'm getting rid of key properties. So I'm just invalidating all those things. And these are all documented. These are numeric values that don't really make sense to you now, but I'll show you. If you look at the wiki doc, it has all that docked in there. So now that I've invalidated all the properties of the raster, now I can update them. So in the update raster info, I'm actually constructing the raster. what the output raster is going to look like. So I'm setting the band count to 1. I'm defining output statistics because I know what the output statistics are going to be, so it automatically generates. Resetting the histogram, setting the pixel type, and these are all documented too. F4 is going to be a floating point. And then I'm defining the cell size. So if you look here, I'm passing in pixel blocks. So the way we define a pixel block is we get the name of the parameter. So the name here is slope, and then I add underscore pixels to it. So this is known by the Python raster function as a pixel block. So my in block 1 is my slope raster. My in block 2 is my flow accumulation raster, and I'm getting the cell size from the input. So if you look, basically the calculation's fairly basic. We're calculating slope. We're passing this into an equation, and we're outputting a pixel block. And the output pixels is the same thing. So the pixel block would be output underscore pixels. We're updating some key metadata. Here's the actual equation that we have it defined in its own method, but we're actually using it up here. So that's a basic Python raster function. I'll show it to you working. So if we go over here, if you want to import a Python raster function, it's fairly straightforward in Pro. This little burger button over here allows you to do it. You can also do it in the function editor. If I open function editor, this little notepad here will allow you to import a Python raster function. So you can import it directly to your model, or you can import it to your pane. I'm going to import it to the pane right now, so I'm going to open Python raster function. I'm going to choose my Python file. You can have multiple classes in there too, so if you want to have multiple functions in a single Python file and just send that, you can have a drop down and you can choose which class you want. Right now there's only one in there, so there's only one option. So when I choose it, you can see that my parameters are there from my Python file. If I hover over, it should give me a description. That's really hard to see. But yeah, it has description, which is in my update parameter info method. So once I have it open, I can save it, give it a name. I can call it CTI. Click OK. So now I have it here. Just like any other function or function template, I can use it in the function editor. I can chain it together with other functions, and it's just like any other function to the end user. So you can create these templates with Python files and send them to end users, and they don't need to know anything about Python, and they can use them just like any other function. So let's apply it. So I have a slope raster and a flow accumulation raster, and then I can create a new layer. And you can see it's just as fast as the out-of-the-box functions. Renders fairly quickly. It's okay. And it's very performant, very scalable. So I'm going to hand it over to Zoey, and she's going to show you. I just want to show you that you can use these in 10x as well, and she'll show you how to apply a Python raster function in 10. So let's do the same thing in 10.
Okay, so first you select one of your raster input. You click here. You click insert function. You can choose to insert a Python raster function. And then you need to find your Python raster function here. For the input, you need to change to the input you want. So here are the two raster inputs you want. You click OK and apply. So here's how you do it in 10x. So back to Jamie.
Okay. So moving along. So now that, oops. So now that now I've shown you how you use the Python raster function, how to use a basic raster function. We're going to talk a little bit about function templates. I showed you some templates earlier, but I want to show you how we work with templates and how we apply them to Mosaic data sets. So templates can be made fairly easily. I showed you a few methods how to do it. You can do it, and you can make them in the template editor. You can export from layer symbology as a template. So I can symbolize a raster, and I can export it as a template, and I can insert it into my model. So now you don't have to worry about how things render. You can actually export a rendering template and make it look good, make it look how you want it to look, and then actually have that in the chain. So the user at the end of the day doesn't have to just apply the template and then go set the rendering options and symbology options. You can contain that in the model as well. You can save it from a function raster data set. So if I go over here, this is a function raster data set. I can actually save this as a chain. I can actually save it as a separate function chain here, right? You can also do it in 10x the same way. So you can do it through the image analysis window. You can do it through the pane in Pro, and you can do it through layer properties. So let's talk about applying them to a Mosaic data set. So like I said earlier, you can have a Mosaic data set, and you can apply several templates to it. And when you do this, the end user, whether it be on an image service or whether it be just on a Mosaic data set, can flip through these templates and apply them to the Mosaic data set. They're very fast. They work really well in all of our web APIs. You can call them through REST and all that good stuff too. So here's a basic template. I'm going to go over in a sec how. You as an image manager create a Mosaic data set, and there's several rasters in there. Maybe you have 10 rasters. How does the Mosaic data set, how does the template know what records from that Mosaic data set go into a particular parameter in a template or in a Python raster function? So I'm going to talk a little bit about how do we define that. So at the end of the day, the user doesn't need to know what record in the Mosaic data set needs to go into a particular parameter. They just need to click on the template, and then it applies. So I'm gonna talk a little bit about that. So here's the properties of a template. When I am getting ready to apply this to a Mosaic data set, and I want to apply it to certain records in there, you're going to want to set it to item group. So you can see here that I have it set to item group, and you're going to have to set fields in your Mosaic data set to define what groups and what items in that group are going into that parameter. So I'm gonna go to my next slide and show you a little closer look. So here I have a Mosaic data set. This is a table from a Mosaic data set, and it has several rasters in it here, you can see. And I don't want to pass those particular items into my template as a parameter. So here I have group name set. Everything's in the same group in this example. So everything's in this weather group, although you can have different groups. So if you have, let's say you're doing like wind chill, and you have a Mosaic data set with wind speed and temperature rasters, you want to group those accordingly. So you want wind speed and temperature from this area, and wind speed from and temperature from this area to go into separate parameters, right? So the group A would be the group maybe over here in California, and group B would be the group over in New York. And then you have a wind speed and a temperature raster for each. So that's where grouping would be. Group A would be California, group B would be New York, if that makes sense. Here I have all one group. Everything's one group. And the name I have set here is a meaningful name representing a raster. And then when I go into the properties of the function itself, I'm going to define that name to be whatever's in this name field. And I'll show you how to do that. I'll show you a working example of that. So here I have a basic site suitability analysis, and I'm going to show you. So what I have is several rasters. These are all in a Mosaic data set. And I'm querying a table. I'm querying a table, and I have a particular operation, a particular variable, and a from and to. So each operation here is going to represent a template. So I'm going to say, okay, where is the most ideal area for air defense? It can be anything, though. And then I'm going to take a bunch of variables, and I'm going to aggregate them. And I'm going to go to this table, and I'm going to say, okay, from between 50 and 100, I'm going to remap. I'm going to do a basic zonal remap and say it's bad. It's -2. -2 we'll say is bad. And then we'll do the same for cloud ceiling. We'll find thresholds for cloud ceiling, and we'll remap it. And we'll do that. We'll do that for several things. And I'll show you how you do it in a template here. So here's the basic structure of how it looks. I have a bunch of weather rasters in a Mosaic data set. I have a bunch of Python raster functions doing zonal remapping. And then I'm going to do cell statistics. So I'm going to aggregate all those together and find out what are ideal areas for a particular operation and what are not so ideal areas for a particular operation. So the code's pretty basic. I'm just crawling through this table that I'll show you. The table's right here. You can't see it. Table is right here. So you see I have a bunch of operations. I have a bunch of weather variables for each operation. I have a bunch of to and from threshold values. And so if it falls within this range, it becomes a -2. So I'm just going to crawl through this table using a Python raster function. I'll show you how quick it is. So that's all the code is doing here in this.
No, extend. Go back to extend.
Sorry, so that's basically what this code is doing. Here's the update pixel method. I'm actually just crawling through this table, getting these values, and outputting to a pixel block. So let's go over and look at this thing in Pro. So here is my Mosaic data set. Right now I have no templates applied to it. Here are all my templates. I'm going to show you again. Okay, so here's my Mosaic data set. If I look in it, you'll see there are a bunch of rasters in it, all representing a particular weather variable. So here's my name field. Just pay close attention to that, because that's what I'm going to be using in a second in the template. So if I open one of these and edit it, these are all Python raster functions here. These are all driven by Python raster function. It's a basic zonal remap function, the one I just showed you. So you'll see I have my input raster, my threshold table, to from values, and the target field. So this is all in that table. And I have a where clause too. So I'm saying where operation is air defense and the variable is visibility. So if you look at the properties of it, I have the tag field name set to name. So that name is, again, connected to this name field here. So it knows to go through that. And then if I go into the actual function itself and look at the variables of that, the name is visibility. So it's going into this table, finding in the name field the record with visibility, and passing it in as a raster to this function. So I have all these made. Now I can add them to my Mosaic data set. So I can go into my project here, open the Manage Processing Templates pane. There's nothing in there right now. And then I can import them all. So you'll notice that new at 1.4, we have this new function browsing experience. You can actually browse. You can browse the areas on disk, but you can actually browse to your function pane. So these actually represent subsections of my function pane. So I can go in here, and you can see all the operational threshold templates that I had in my function pane. So let's add all these to the Mosaic Data Set. I have thumbnails created for them. You don't have to use these thumbnails. You can actually generate thumbnails yourself by clicking on this. They'll actually take a snapshot of the Mosaic Data Set with the function applied and make that the thumbnail. And you can do it for all of them. If you go in here, you can actually generate thumbnails for all of them if you want. But for now, I'm not going to do that because I already came up with my own thumbnails and put them in there. So now that I have them saved in here, I can go over, select my Mosaic Data Set, and hit the processing templates drop down, and you can see them all in here. And the end user doesn't need to know, what parameter goes where. They just need to choose the actual template, and it renders for them. So it's all going on behind the scenes. It's taking a little bit, sorry, the network's a little slow. But here you can see it applied that template, passed all the rasters from the Mosaic Data Set into the function, and rendered it for the end user. And these can be portable. These can be added to. These can be published. These can be accessed through your web APIs. You can build cool widgets so you can access them. We actually have a bunch of samples out there that have functions driving some web apps. So it's very fast, very easy for end users as well. Does that make sense? Is that confusing? Okay. Okay. So I want to give you a few extra considerations. Don't use ArcPy in these things. We want to avoid looping through pixels because that's going to degrade performance. Seriously, you want to stay in the array realm. You want to use NumPy, SciPy, scikit-learn, scikit-image. There's a bunch of really cool array processing libraries out there. We do have the option to use Python files. So for those of you using Python, we thought there might be a performance improvement with Python, but we've not really noticed it. It's good. It's good if you don't want people seeing your code. If you want to send this to people and you don't want them, if you want a binary version of your code that people can't look at your algorithm. So we kept it in there. So you can use Python. You can use Python files in the Python raster function. Python versions. This is something you kind of have to pay attention to if you're going to be jumping back and forth between Pro and 10x. Pro is at desktop is at 2.7, Pro is at 3.4. So if you're installing libraries, make sure you have both if you're using both. Make sure you have all package dependencies. So if you're developing these things and sending them people, make sure that they're aware of the packages necessary to use these things. Publishing and deployment. So we've changed our publishing and deployment story a little bit with this. At one point, we were thinking about just sending the Python file along to the server if you're publishing these things. So I have an image server of Mosaic Data Set with a Python raster function attached. I'm publishing it to ArcGIS server. We were sending the Python file along with it, but we had to change that story because there were some concerns from people about maybe having Python containing malicious code and them sending it to an ArcGIS server and having it out there. So we decided to develop this thing called the well-known home folder. And what the well-known home folder is, it's a known location on all of our applications. So in 10, in server, and in Pro, and it's here. So when deploying these Python raster functions, we're recommending that people put their Python files and their RFTs in this folder across the board. So if you're a server administrator and someone wants to publish a Mosaic data set with Python code in it, you have to send that Python code to the server administrator with the RFT. He can examine it, make sure there's nothing malicious in it, put it in this folder, and then when you're publishing the Mosaic data set with Python raster function, it works. We want people, in 10 you can use a actually across the board, we want people to use this folder structure. So this functions catch-all is known by the software as the install directory, and I'll show you where that directory is. So you can reference in your RFT the actual path to the Python code using this. So this assumes install directory, and I'll show you that directory. And new at Pro 1.3, if you put your Python code and your templates in this well-known home folder, it'll actually auto-generate on the pane. So as an end user, you just have to open Pro and it's there. So they just put these files in this folder and open it, and it's just there. And I'll show you how that works really quickly. So I have some Python files and RFTs. In my RFTs, I am referencing the Python files using the well-known home folder structure. So this folder is here. I'll show it to you on disk. Let me open another one. So it's under, I'll show it to you in Pro. It's the same for all of them though. So it's under ArcGIS, Pro, Resources, Raster, Functions. So if you look at this, this assumes that path, this functions keyword here. And then beyond that, you're going to create a custom folder. So create a folder called custom. And in there, you can create subdirectories. So I'm going to call my subdirectory my Python functions. Copy. Oops. I'm going to go in here and create a new directory called my Python functions.
No, it's not copy. Just type in.
I'm not working. My OK. So now I'm going to move my Python files and my RFTs into this folder. Say yes. So now, I'm going to have to restart Pro. Give me 1 second. So now when I restart Pro, and take note of what I call the subcategory. So I call it my Python functions. This is actually going to be the name of the subcategory in my functions pane. So you can have several of these. You can have custom my Python functions 1, my Python functions 2, and these will all show up as subcategories in Pro as soon as it opens. Give it a sec to load here. OK, while Pro's loading, I'll talk a little bit more. So I just want to mention that we do have a GitHub repo if you guys want to visit it. We're constantly adding new functions to it. We have users that are actually jumping in on it now and starting to make pull requests. So if you want to visit the Python raster function GitHub repo, I suggest it. We're pretty active on it. If you have questions, there's a couple of us that are pretty active in responding to questions on there. We do have a wiki on there, so all of our doc is handled through the wiki on there. I don't think we're docking it in the software as much. I think most of our doc updates are going into here. So yeah, go in and look at that. If you have any questions, ask us. Pro's now up. It's not. Here we go. So I'm going to show you how that well-known home folder thing worked. So if you look on our functions pane when this opens, so if you look here in our custom pane, still not seeing it. So if you look here in my functions pane, you'll see that I have a new subcategory. And the Python and raster function categories are denoted by these square parentheses here. So you'll know that this is generated from that well-known home folder. So it auto-generates. So you as a developer can build these things, tell the user to put them in this folder, and then it's all right there. They don't even have to import the Python raster function at that point. It just auto-populates. That's only available at 10 now. Or at Pro, sorry, at Pro. So yeah, so if you guys have any questions about the Python raster function deployment, yes?
Something about grouping things. I think you were using the Mosaic catalog to figure out how to group things.
Uh-huh.
If we want to write one of these function chains against ArcGIS online content, do that, and how do we get to that information?
You can do it the same way as long as they have catalog access to the image service itself. So if some people are publishing these image services with no access to the tables, if there is table access to these image services, then you can do it the same way.
How do you get table access to the image service?
It depends on the publisher. If the publisher is actually publishing it with access to the table or catalog access, then you can. If not, then you can't.
If they did it, how would I find it?
You should be able to just drag it into a desktop client and open the table. So you can just open, if it's grayed out, then they haven't enabled catalog access. And then it's just like a static image that you can use. But if they do, then it should not be grayed out. And you should be able to open it up just like any other image service. No problem.
I have a question. So now we're using the OpenCV to read the pixel values about some geotape. There are different formats for the geotape. Some are row-based, some are tile-based. So based on your Python API, that's smart enough to handle different formats?
Yeah, it is, because it's all handled through our raster library, which is Github. So if ArcGIS reads it, then the Python raster function reads it.
Thank you.
Have you bundled up Github, or is that something you also have to have in?
Github comes with desktop, so it's already there. Any other questions?
So are you sometimes chaining functions inside of Python, or you use Python just to create?
Yes, you can't read existing functions in Python, like an out-of-the-box function. So right now it has to be handled at the template level. So if you're doing a bunch of stuff with out-of-the-box and Python functions, Python will be a first-class item in that model. It'll be a node in the model, and you can chain it together with other things. We don't have a way of calling out-of-the-box functions in Python. Not yet. There's been some people asking for that, and it might be something we want to consider. So you can do everything within your Python module and not have to build a giant chain. But yeah, not yet.
So when you deploy, you have to send both Python function as well as templates, both of them, or just the one thing?
Both.
Okay.
Yeah, both, because the template references the Python file in a particular way, that with using that folder structure that I showed you. So yeah, we typically recommend you send both to the server or portal or wherever you're using it.
So we're trying to integrate the Python functions with ArcGIS Python API. Like, are you familiar with that?
We don't really.
REST API thing.
The REST, it works with REST API. You can call these functions in the REST API. The Python API, I'm not sure at this point if it's tied into that.
I think it supports.
I was wondering if you guys, I've been doing some of these, and when you go to the REST API, you know, it lists the function templates. At some point, are you going to list like the parameters there for function? Because sometimes function templates can have parameters that you pass in. Say from the.
You can't do that at this point. I'm not.
It does. It just lists the name of the template. It doesn't list any of the parameters for the template. You kind of just have to know those. You know?
Yeah.
Which, you know.
Yeah, it's kind of annoying. I agree. That's something I'd have to talk to our web guys about. I'll make note of that and talk to them. We have a few guys that work on the REST API. I don't work on it directly, but I work with them. Let me write that down.